Hi, my name is Alana Hudson, and welcome to my Lab 3 presentation, Black Hole. This lab was essentially about using computational model to replicate the motion of a star with a given mass to determine the unknown mass of a black hole while analyzing the relationship between forces and the change in momentum. We used GlowScript Visual Python to produce a computational replication of the star's motion. The results for this lab showed that using the momentum principle and Newton's law of gravitational force, the mass of the black hole was 1.6 e to the 34. The significance of this lab is that it helps to show the nature of a single force, in this case, gravitational force, the factors that affect its magnitude and its effect on other objects' motion. The fundamental principles used in this lab were Newton's second law, the momentum principle, and Newton's universal law of gravitation. Particularly for the momentum principle, we paid attention to the components, the parallel and perpendicular, which equations you can see in the picture on the left. We use GlowScript to analyze the star's motion and to find the black hole's mass. You can see in the first screenshot on the left that we started with putting in the star's mass, which in my case was 2 e to the 30, and delta t being the seconds in a full day. We also use the while loop at the bottom to compute a velocity of the star for both the x and y components by taking the difference in the displacement and dividing it by our time step. In the second screenshot, you can see that we use the momentum principle, the parallel and perpendicular parts for the rate of change of momentum, correlating to the highlighted red box. At the bottom, you can see that we computed the mass of the black hole using the gravitational force equation. In this lab, GlowScript computed the FNet, parallel, and the FNet perpendicular, all their magnitudes, and resulted with the mass of the black hole, which in my case was 1.62133 e to the 34. And the video shows this on the left, where you can see the forces moving with the arrows, and the star moving around the black hole, which is the black figure in the middle of the screen. Overall, the mass of the black hole was 1.6 e to the 34, and compared to the star's mass, it is about 7,500 times larger than the mass of the star. We configured the equations for the momentum principle. We used GlowScript to code the model prediction utilizing the momentum principle to compute the mass of the black hole. We compared the black hole mass to the star mass. And as far as the error analysis for this lab, I believe there were no code errors, and so the data should be accurate. What does it mean? So in discussing how the net force and its parallel and perpendicular components are different from the rate of change of momentum and its parallel and perpendicular components, you have to consider that it's all about the causes and effects of the two. So for the perpendicular, in the case of net force, the perpendicular causes the star to change in direction. For rate of change in momentum, the perpendicular refers to the rate at which the star's path changes. In other words, the curviness of the path or the motion of the star. For parallel, the net force, the parallel causes the star's speed to change. But for the rate of change in momentum, the parallel refers to the rate at which the star's speed changes. In other words, the star's acceleration. What if, imagining the black hole's mass who we found was removed and a different black hole was placed in the same location, assuming the motion of the observed star remains unchanged and is affected only by the gravitational force of the new black hole, could you tell the difference? Keeping in mind the only force acting on the star is the black hole's gravity, and the factors that affect the gravity is the gravitational constant g, the mass of the two objects, and the distance between the two objects, you will not be able to tell the difference because everything will remain the same and the mass of the new black hole would be the same as the old black hole, hence the star's motion being exactly the same. Thank you so much.